books, when we start with the rotational mechanics or rigid body mechanics, this is the one term which come across is moment of inertia. So what is this moment of inertia? The only word which we have heard so far is inertia, that is, or what you call as linear inertia. And we had said that is if there's a big truck, this is truck, and this is small car over here, let's say electric vehicle, this is car. And in case, suppose they are not working and we have to push them, it is very easy to push and put it into motion. It is very difficult to put it in motion. That is, inertness towards the change of this truck is more as compared to inertness of this car. This car can be easily put into motion and it can easily be stopped. Whereas this heavy truck, it is difficult to put into motion, and once it is put into motion, then it is very difficult to stop it. Then over there we said that is inertness towards change of this truck is more than that of this car. Then we say that is when we say inertness, when we have used these words in our Newton's laws of motion, you must be remembering very well. Then we say that is this more and less, they are the comparative terms. If you say that this line is bigger than this line, that is fine. But if I draw a bigger line, longer line, then this line becomes shorter than this. So that is bigger or smaller, they are the comparative terms. We want some specific. In science, we want to be very, very specific. That is what is how to quantify it. Then we said that is we quantify it by using a word mass. That is, we say mass of this, suppose it is 10,000 kg and mass of this is 1000 kg. So this is clear that if the mass is more, then the linear inertia is more, or inertia is more. Now we come to rotational mechanics. So when we say inertia is more, linear inertia is more, so it is something that is inertness towards a change towards pure translation. But when we talk about the moment of inertia, that is moment of inertia, we can call it as mi or simply as I. So moment of inertia is what? It is the inertness towards, let's say, rotation. Let's say this is axis. This is y dash is axis, and there are two drums. This is a smaller drum and this is a bigger drum. So it says that is, it is very easy to put this drum into rotation. Let's say you can rotate about this axis, about this spindle, you can easily rotate it. Whereas if this is a heavy drum, it becomes very difficult. Or even if the same mass is there, it is difficult to put this drum into motion as compared to this, even if the mass is going to be same. So, and similarly, if both of them they are rotating at some angular velocity, it will be difficult. It will be more difficult for us to put it to stop as compared to this. So we can say that is rotational inertia of this body about this axis bigger as compared to moment of inertia of this smaller drum about this axis. There is no word like rotational inertia. We have the word same thing, that which means the same thing is moment of inertia. So moment of inertia, we say, of this body about this axis is bigger than the moment of inertia of this body about this axis. This moment of inertia, once again, as we have quantified over here in terms of mass, similarly over here also we have to quantify, that is what is moment of inertia, how we are going to measure it, how we are going to quantify it. So when we say moment of inertia of a body about an axis, suppose this is a particle mass m and this is an axis is denoted by, let's say, y dash. So we say I y dash. What does it mean is moment of inertia about this axis of this particle, that is m, and this distance is, suppose perpendicular distance is r, it is going to be of this particle is mr square. Remember, whenever we are going to say moment of inertia, it is always of a body about an axis. In whole rotational mechanics or rigid body mechanics, we are going to give due regards to the axis of rotation. Many times students say that is moment of inertia of a ring is mr square. No. Whenever you say moment of inertia of this body, you have to mention about which axis. Moment of inertia of a ring about an axis passing through the center and perpendicular to its plane is going to be mr square. We'll come to these things. But the important thing right now to understand is whenever you say the moment of inertia of some body, you always have to say about which axis. Now, there could be two kind of cases. One is a particle. It is a small particle. We can find the moment of inertia of this particle about an axis, or we can have a continuous mass distribution. Let's say we can have this bigger body, this lamina we can have, and we have to find the moment of inertia of this body about this axis. So this is composed of so many particles. They are composed of so many particles. So this is a continuous mass distribution. This is a particle. So moment of inertia of particle is mr square. Similarly, when we have to find the moment of inertia of this continuous mass body, what we can do is we can break it into small pieces, that is m1 or dm, or let's say we can say m1, m2, m3, and we can find through integration the moment of inertia of this whole body about this axis. We can find it using concepts of integration. We'll come to that. But Right now, the thing to understand is we can have moment of inertia of a particle about the axis, we can have a moment of inertia of continuous mass distribution about the axis also. But the main thing is remains as moment of inertia of the particle is going to be mr square. If there are two particles, m1 is over here and m2 is here, this is r2. We have to find the moment of inertia of system of these two particles about this axis. Then Iyy dash is going to be summation of, let's say, moment of inertia of these two particles about this m1 r1 square plus m2 r2 square. And if you have more particles, you can keep on adding and you can get the answer.